I mean, it is sort of it certainly requires a different mindset, right? You have to really trust that you understand what your detectors are doing, that you understand how they work, that how they respond when they detect these things, and you really have to be able to, sort of construct models ahead of time that say, well, if this sort of particle is involved in this reaction, then that means that we observed this and it has these properties, and we can learn a great deal about that. I mean, we've been able to, in the field of sort of classical nuclear physics, which I don't really do, they're able to talk about the shape of nuclei, which is not something that we can really directly observe, and how they oscillate and things like that. So we've gotten very good, between sort of the theoretical side of physics and the experimental side of, constructing these models and, figuring out what we should measure to actually tell them. But you're right, it does. One of the big challenges I have is, trying to paint a picture in my head of what's really going on, right? Trying to come to grips with what are we actually seeing here. It is frustrating at times, but fun too.
Mark, Scott?
I guess
since y'all are on the other end of the spectrum there.
Well, like you said, it's kind of the challenge and the fun. The scientists are always going to be pushing the envelope anyways, so if it's easy to see, then you're not as interested. So you're always going to be pushing the envelope and trying to go for the thing that's hard to see. And
I guess part of pushing the envelope is building bigger telescopes. Like in California at the minute, they have a project to build a telescope with a 30-meter mirror. And the idea there is that they'll just be able to see things that are even further away. They're trying to look for objects in what they call the cosmic dark ages, basically the first stars that turned on. So, yeah, we're pushing the envelope. We try to find things that are further and further away and more difficult to observe all the time.
And this is sort of a fantastical question as a follow-up, but in each of your areas, do you even envision the possibility that your science will become a little bit more tangible down the road? I mean, even if it's 100 years from now, because now it is a bunch of things that you can't directly experience tangibly.
I guess we're not anticipating that in our field. I mean, there's never going to be a point, I don't think, where we'll be able to, have a microscope that looks directly at a quark and a proton. The distance scales are just too much. I mean, that's what we're doing with the accelerators. We just have to. It just requires a lot more interpretation, and so the detectors in our equipment become our eyes. Working as a particular regime of light or whatever. So it's probably never going to be to the point where we directly image something like that. But we've become pretty good at reconstructing these things from some fairly esoteric phenomena that we observe. So. I guess to kind of follow up on all that, the point at this point is, in both astronomy and in particle physics, if it's easy, it's been done already. So we have no choice but to build these bigger and bigger machines and get even more and more intangible.